Hello everyone, this is Paloma, your PMP coach. I'm going to be talking about the critical path method with an example that we had previously explored. So this is a video 2 out of 2. We had looked at this problem before and we had identified that the critical path was actually A, B, E, and J here. Now the question is asking, what's the float of D? So D is falling outside that critical path. Thus, if they're asking me for the float, there's really no way around it than to actually perform the forward and backward pass so that I can find my float. The box at the top right, you can see that I have created this convention so that I can understand where to place the early start, the early finish, the late start, the late finish of each of my boxes. And then I can also place the duration and the total float. Usually the duration will be given, so I'll be able to place it here. But the total float, I'll be able to put it in a methodical way somewhere where I can always retrieve it. I do this because it becomes really cumbersome and tedious and confusing over time as the diagram grows to keep track of what number belongs where. So it's very important that you keep an order as you go through the forward and backward pass. To solve this problem and to find the float of D, I'm first going to have to do a forward and then a backward pass. So let's do the forward pass. This is the equation of the forward pass. I'm basically going to take the early start at the top left plus the duration that I have. I'm going to subtract 1 day, and that's going to give me the early finish at the right. I know my project always starts on day 1. So I'm going to place a 1 right here at the top left of my activity A when I start. So I apply that equation, 1 plus 4 minus 1, then the early finish of activity A is going to be 4. Now, if I was to take, I can say that activity A is done on day 4. So that means that activity B and C have to start on day 5. Then I apply the equation again on activity B and activity C, according to the early start and the durations that I have in there, and I'm never forgetting to subtract the 1 at the end as I do a forward pass. So B has a 9 early finish and C has a 6 early finish. Now for C, activity C ends on day 6, so activity D is going to start on day 7. Then activity B ends on day 9, so activity E and F are both going to start at day 10. I again apply those formulas and I obtain the late finish of each of those activities. And you see how I'm going methodically, vertically, right? I am not trying to finish one branch and then move to another branch. And the reason for that is because a lot of these have dependencies with each other. So I need to know the connections between them before I move on to the next box. So we're going to see an example now. If you look at activity I depends on activity E. Activity E finished on day 15, so it's going to become on day 16. But then if you look at activity G depends on 3 different other activities, E, F, and D. So this is why I don't want to finish one branch and then continue through the other. I need to finish all of them vertically at the same time so I can choose which of these early finishes I will use to start the next activity. So I actually need to choose the highest number for this early finish, which would be 15 over here from activity E. So that means that activity E is the one that finishes on day 15. So F finishes on day 13, D finishes on day 8, much earlier than activity E. So I'm going to start activity G on day 16. And activity H only depends on activity A as seen by the arrow. So if activity D ends on day 8, activity H is going to start on day 9. Then I apply the formula for each of these and I can obtain the early finish. And then I can see all the arrows converging into activity J. And so I again choose the highest number because that's the latest or the early finish of that activity, which would be day 21. So then this activity J is going to start on day 22. And then I know that the whole overall project lasts 24 days. Now, to be able to know float, I need to do the backward pass. So to do the backward pass, I'm going to apply this other equation, which is taking the lower right corner box, late finish. I'm going to subtract the duration, and I'm going to add 1 to find the LS, the late start. So I'm going to lower the 24 from here, and then I'm going to apply that. 24 minus 3 plus 1 is 22. Then I can see J has links to I, G, and H. So since J will start on day 22, as seen in that late start, then the other boxes that are preceding it need to start on day 21. And then I apply the equation again, carefully, making sure that I'm adding that 1. And I can find the late start for all those activities. Then I need to go slowly here because this is where things get tricky, right? And this is why I am not finishing one branch and going to another. I'm going to try to go as vertical as I can. So here, activity D has a link to activity H. And so it's going to be a day before. The late finish is going to be a day before the late start of H. Then F depends, has links to activity G only. So activity G start is day 16, so activity F is going to be day 15. And activity E has links to G and I, so I need to take the smallest number out of these two, which is the opposite than the forward pass, right? Where we took the largest number. Now I'm going to take the smallest number. So this means that activity G started on day 16, which is the earliest late start that I have. So activity D is going to end on day 15. Then I apply those formulas and I can find the late start for all those. And then I can see that for activity C, I have a 13-day late finish. In the case of B, what I'm going to do is choose the smallest number out of these two because I'm doing a backward pass. So it's the 10 that I'm going to choose. So it's activity B is going to have a late finish of 9. I apply those formulas again, and activity A in this case would be a late finish of 4 because the 5 is over here, is the smallest out of these two. And then I can see that it ends in 1, which is excellent. Now I need to find the float. Once I do the forward and backward pass, that's all I need to get the float. And so to do that, basically I need to subtract the late finish minus the early finish, which should be equal as the late start minus the early start. That should be the float. And I'm going to put it right in my box over here in the middle where it says total float. So I go through it. I can see that both numbers need to be the same on both sides of the box. And I can put those numbers here. You see how I'm filling them out. And I can see a lot of zeros, which is good because that shows my critical path. So I can confirm that A, B, E, G, J, which I had mentioned to you was the critical path, is indeed the critical path because it has a float of 0. So now going to activity D, I can see that the float over here that I found was 7 and that on both sides is 7. If you ever find that one side is different than the other, then there's some issue, some problem somewhere here. So you're probably going to have to walk through a forward pass again and a backward pass. Usually what students miss are the plus or minus 1, somehow confuse it with the forward backward pass. So just make sure, that's what I'm saying, that you go slowly and methodically and you know exactly when to apply which. So that's pretty much it. That solves our problem. If you do this carefully and slowly and orderly, you should be able to get it right the first time. All the conceptual side of things, you should know it by heart. And then there's just a matter of practice, making sure that you don't make any small mistakes like missing the negative 1. But yeah, that's pretty much it for this type of problems. Let me know if you have any comments about this, and I'll see you in the next lesson.